In this video, we'll continue to look at domain and range. If g of x is equal to 1 divided by x plus 3, find the domain of g. Now, one of the things that we need to consider when we're talking about the domain of a function is if we have a fraction, the denominator cannot equal 0 because division by 0 is undefined. So in this function, our denominator, x plus 3, cannot equal 0. So to find our domain, we're just going to need to solve this inequality. Now we can do that to isolate the x. We subtract 3 from both sides. These will cancel, and we can see that x cannot equal negative 3. So our domain, if we wish to write that in set builder notation, the set of all x's, which are elements of the set of reals, such that x is not equal to negative 3. Remember, this symbol is an element of, and the vertical line replaces the words such that. Do another example. We're asked to find the domain and range of the function y equals square root of x, and then graph the function. Something else that we need to consider for the domain of a function is that we can only have real numbers. So if the radicand here, or the number that's under the radical, if that's negative, then we're dealing with imaginary numbers. And that is a restriction on our domain. So this x, which is the radicand, x must be greater than or equal to 0. We remember that we can do the square root of 0, so 0 is allowed in the domain, just not negative numbers. So our domain then is equal to the set of all x's, which are elements of the set of reals, such that x is greater than or equal to 0. Now we're also asked to graph the function, so let's do a XY chart over here on the side. I'm going to look at x values that are perfect squares so that I can get a nice y value. I have to have x greater than or equal to 0, so let's start with 0. The square root of 0 is 0. Then our next perfect square, x is 1. The square root of 1 is 1. Our next perfect square is 4. The square root of 4 is 2. And our next perfect square is 9. The square root of 9 is 3. So let's graph the point 0, 0, 1, 1, 4, 2, and 9, 3. So our square root curve looks like that.